Start, sir. Start, sir.
Okay, right. This is Yashoda Krishna. You have to watch. This is Yashoda Krishna. You have to watch part 1, part 2, part 3 before going at the part 5. Before going at the part 5, current electricity, second year, sixth chapter. Last class, I thought potentiometer, total potentiometer. Potentiometer, what is that potentiometer? To measure potential difference more accurate as compared to voltmeter. Potentiometer, potentiometer. What is that potentiometer? Potentiometer is nothing but to measure for potential difference, more accurate compared to voltmeter, more accurate, accurate to compare as compared to as compared to voltmeter, 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 or as compared to voltmeter. What is that voltmeter? But voltmeter is more used often due to a small in size. Voltmeter is a small in size, more convenience compared to potentiometer. Here, more accurate values. Potentiometer is nothing but it is a measure for to measure for voltage difference. Voltage difference to measure for voltage difference. What are the uses of potentiometer? What are the uses? First one, to measure EMF of cell. To measure to measure to measure EMF of EMF of cell. EMF of cell. To measure EMF of cell. To measure EMF of cell. Okay, right. Second one. What is that second one? To compare EMF of two cells. To compare EMF of two cells. Two cells. Okay. Third one. Third one. To determine internal resistance of. To determine. To determine internal internal resistance of cell. Internal resistance of cell. To compare, to determine internal these are three more useful by using potentiometer. What is that potentiometer? Let us just see. Last class I thought, but I repeated once. Okay, right. Next one, construction. What is that potentiometer construction? Construction of potentiometer. Construction construction of potentiometer. Construction of potentiometer. What is that? Here, one total battery. That battery is connected to rheostat RH, and connected to one K key, and this total is connected to one uniform potentiometer wire. Uniform cross section wire. This is the uniform cross section wire. This is the uniform cross section wire, total uniform cross section wire. Okay, this is the A, this is the B, uniform cross section wire. This total consists of on a wooden box, wooden box. Okay, right. This total, what is the long wire, long wire of uniform cross section area? This is the long wire, about 4 meters to 10 meters. A long wire, a long wire, a long wire of uniform cross section area, uniform cross section area. That this is the uniform. If wire is like this is the uniform cross section. This wire have a uniform cross section. uh, Here cross section area is constant. Here this for this case, this cross section area will be increases, not constant, not uniformly. This is not a non-uniform wire, non-uniform wire. This is the uniform wire, uniform cross section wire. Like that wire is there for A to B. This total consists on wooden box. Okay, right. What about this total length is L? Total length is L. Here total potential of battery, total potential of battery in this is the primary circuit, primary circuit. This one is the primary circuit. Primary circuit consists of battery, rheostat, key, and total wire. Okay, right. Here primary circuit, this length of the wire, total length of the wire, length of the wire L, length of the wire L. Potential drop of battery, potential drop of battery V is there. First V, total V. Okay, for L, for unit length, 1 unit length, how much of potential drop? V by L, V by L. For x units, how much of potential drop of battery? V by L into x, V by L into x. X is the x unit, V by L into x. This is the total. For example, for A to C, this is the C is there. Now this length AC is there. That AC is equals to x. AC is equals to x. How much of potential drop from A to C? A to C. How much total? How to find out the total length? Length is equals to how to find out total length? V is equal V by L into x, total battery. To finding total length of the wire, total length of the wire L, total length of the wire L, potential drop V is there. 1 unit for you, for 1 unit length, how much of potential drop? V by L. X units, V by L into x. That is the most important idea. This is the primary cell, for primary cell. What about total potentiometer? How to work a potentiometer? First use, what is that first use? That is nothing but uh, to determine the to determine EMF of cell. How to determine EMF of cell? By using potentiometer. By using potentiometer. Let us see. That is the most important. Okay, right. Here, here, what is that? To measure EMF of cell. First one, to measure to measure EMF, electromotive force of a cell by using potentiometer, by using potentio potentiometer. Potentiometer. Okay, right. That is that. How to write? How to that one? Okay. This is the battery. Battery is connected to a rheostat or rheostat. Here, one key is there. That is the K key. This is the primary circuit. Total. This one is the primary circuit. Primary circuit have a this one long length wire, potentiometer wire. This is the potentiometer wire. This potentiometer A is connected to one battery. One battery. Okay. Internal resistance. This is connected to galvanometer. That galvanometer connected to jockey J. Jockey J. Jockey J. This is the C point. This is the X. This is the X. A to B point. This is the battery. EMF E is there. E is there. How much of how to find out? Total length is equals to L. Total length is equals to L. Total length is equals to L. Here, listen. All of you listen carefully. When the current processing from one place to another place, when high voltage region to low voltage region, when the voltage difference is there, when the voltage difference is there, then only current processing from high voltage region to low voltage difference is there na, then only current pass, then only current pass from one place to another place. Otherwise current does not flow. Otherwise current does not flow. Here voltage difference. Here battery is there. This is the primary circuit, this is the secondary circuit. Here G is there. G is there. Here this is the secondary circuit. Okay, primary circuit. This one is the primary circuit. Primary circuit. When the key is connected, when the key is closed, when the key is closed, current processing in primary circuit, current process total primary circuit. Here, jockey J, this end of the wire connected to battery, and that battery, from the battery connected to galvanometer, from the galvanometer connected to jockey J. Jockey J is touched to on wire any point, on any point of the wire, any point of the wire. That jockey J connected any point on wire, potentiometer wire, any point. Okay, that is the jockey J working. Okay, right. When this jockey J, if it is this one is the jockey, this jockey connected to galvanometer, then what's happened? Jockey J connected from A to B, some points, connected to some points, or travel, jockey J travel from A to B like this. Then what's happened? When some place, at some place, this jockey J reached, at that place, null deflection is there. Null deflection means there is no deflection. There is no deflection on galvanometer. Stick of the galvanometer, there is no deflection. At that point, you indicate that length is X. How to find out that total length? Okay, right, X, that point is X. Okay, that point is X. Here, total, listen, length of the wire. here for x distance, for here this minus value, minus terminal is connected to minus terminal of battery, okay, right? This, if it is 0, this is the V voltage. 0 connected to this one, A have a 0 volt, this one also have a 0 volt. For this end of the battery have a, here V is there, here also V, here also V. If it is your rheostat, resistance of the wire will be increases, this total value will be decreases. Your V is total, maybe decreases. How much of value decreases? Minus IR. V minus IR. This is the V minus IR. If R is 0, R is 0, total R is 0, rheostat value will be 0, then what's happened? I into R is 0, R resistance of the rheostat total, if you connect it to 0, then what's happened? Total value is 0. The year V minus 0, V is there, V is there. The year to year V, year to year V. Then here null deflection, what is that null deflection? Null deflection means what is the galvanometer to measure for a small amount of current. Galvanometer will be used for a small amount of current, to measure for a small amount of current. Here null deflection, if stick of the galvanometer indicate 0, then what's happened? There is no current flow, there is no current flow. There is no current flow means what? Here total potential difference of the battery, potential difference of the battery, and here potential difference is 0. Potential difference is, when the potential difference is same, potential difference is same, then what's happened? Current does not flow for this total circuit. Current does not flow for on this circuit. Then what's happened? Potential difference is the same. Potential difference is the same. How much of potential difference from year to year? Year to year. Last class, I thought. Okay, what is that? Total your length L is there. Potential difference V. For unit length, V by L. V by L. For x units, V by L into x. This is the potential difference from year to year. V by L into x. V by L into x. Here 0. This is the 0. For year to year, potential will be increases by this battery. That is nothing but E. E is there. Here E is there. Here E is there. Here E is there. Here resistance is there, but potential drop equipment is there. But here E. Why did you take here E? Why did you take here E? Does not change because of current does not flow. Current does not flow for this circuit. That's why here potential difference does not change. For year to year, 0. But year to year, E will be increases. Potential gain due to battery. Here E is there. Here also E is there. Potential drop. This wire have a potential drop, but here current does not flow. That's why here potential does not change from year to year. That's why here what is that? Potential drop for potentiometer, V by L into X. V by L into X is equals to epsilon or E, EMF of battery. Then what's happened? E is equals to V by L into X. V by L is a constant. V by L is a constant. What is the V by L? V by L, potential drop for unit length. That is the constant. That is the constant. That a constant is indicated with K or pi, whatever it may be, pi. You have to take a pi. This is the potential EMF of battery. EMF of battery is equals to pi into X. Where pi? What is the pi? Pi is nothing but constant. What is that constant? Potential drop per unit length of the potentiometer wire. Potentiometer wire. What is the V by L? V by L. What is the V by L? Potential drop per unit length on potentiometer wire. Potentiometer wire. This is the uh, this is the to determine total scenario, to indicate to measure EMF of cell by using potentiometer. Here potentiometer for year to year, what is the potential difference? V by L into X. But here does not, current does not flow for secondary circuit, because this is the balanced, this total is balanced. How to identify this circuit is balanced? How to identify this total circuit is balanced? When the stick of the galvanometer indicate a zero, null deflection, then what's happened? Total here total current does not flow. That's why here E is there, here also E is there. This E, year to year potential difference V by L into X, and year to year by using this one, here E is there. That E is equals to EMF of battery is equals to pi into X. What is the pi? Constant. Constant is nothing but here how to determine, how to define that constant? Potential drop per unit length. For which? Potentiometer wire. For potentiometer wire. Can I rub this? 1, 2, 3. Okay, right. Next one. Next one. To measure, if you take one problem, you can understand that concept. Okay, all right. This is the battery. This is the battery. This battery connected. What is that? This primary circuit. 20 volts. 20 volts. Total 10 meters. 10 meters of potentiometer wire. This wire A and B is there. A and B is there. This is the 8 volts battery. 8 volts battery. Next, this is the galvanometer. That galvanometer connected to jockey J. What is that? A null deflection. Null deflection. Which potential indicate for which potential at which potential indicate null deflection for? Okay, which potential? Okay, right. Here V 8V is there. 8V. Okay, right. Right. Here, how much of potential? Total potential here V is there. For unit length, V by L into X is equals to E is there. Okay, for using of this principle, E is EMF of battery, E is EMF of battery, V is total EMF of cell, EMF of cell. This is the battery. This is, two batteries are there. One is the for secondary battery, secondary circuit battery. This is the primary circuit battery. Primary circuit battery is the known battery, known value. This is the unknown value. Okay, right. This 20 by here 10 is there into X is equals to 8 volts. 8 volts. Then uh, 0 gets cancelled. 8 by 2. 8 by 2. 2 ones are 2 fours are. X is equal to 4 meters. X is equals to 4 meters. That is, length is equals to 4 meters. For this is the problem for potentiometer. Problem. Okay. Problem for potentiometer wire. Okay, right. Next one. Next one. What is that next one? To compare comparison of EMF of two cells. Comparison of EMF of two cells. Comparison of EMF of two cells. Next, use use of use of potentiometer, use of potential, second use of potentiometer. Let us discuss second use of potentiometer. Okay, right. Second use of potentiometer. Second use of potentiometer. What is that? Comparison. Comparison of EMF of two cells. EMF of two cells. Two cells. Okay. All right. Here, this is the V. This total potentiometer, total block diagram. Okay, potentiometer wire. This is the potentiometer wire. This is the potentiometer wire. Okay, this potentiometer wire. Battery V is there. Okay, primary circuit, primary circuit, primary circuit. This total. It is most important. Polarity. Here minus is there. Then on here also minus. You must draw. There are, these are same. Then only you can find out the values. Then only you can find out the values. K1, K1, next one, second battery. This is the internal resistance. Okay, K2 battery is connected to one galvanometer J is connected to, okay, jockey J. Then what's happened here? Zero is there. This one is the zero. Minus indicate zero. Okay, right. This is the V voltage for here. Zero voltage here for A. Here zero voltage for here. V voltage. If listen, all of you listen carefully. K1 is closed. K2 is open. K2 is open. K1 key is closed. Then what is the primary circuit? Total. This is the primary circuit. This is the secondary circuit. This is the epsilon 1 or E1, E2. E1, E2. E1, E2. Okay. If this one is the close, then what's happened? Current total. This is the total closed circuit. When jockey J travel from A to B at some distance, after L1 distance, this stick of the galvanometer indicate 0. That is nothing but null deflection. Null deflection means what? Here total current passing to secondary circuit 0. Current passing to the total secondary circuit is 0. Then what's happened? Total potential drop, potential difference is the same. Total potential difference is the same. Right? How to write? Here epsilon 1 is equals to, what is the formula? E is equal to V by L into X. V by L into X. Here total length of the potentiometer wire, L is there. That's why V by L into X is equals to, here X is equals to L1. X is equals to L1. That value substitute on that equation, you will get epsilon 1 is equals to, this is the K into L1. This is the first equation. If K1 is closed, K2 is open, then next one, if K1 is open, K2 is closed, then what's happened? secondary circuit, this secondary circuit will be changed for total circuit, closed circuit. This is the closed circuit. This is the closed circuit. Same process will be going on. Same process will be repeated. Jockey J travel from jockey J travel from A to B. Then what's happened for L2, for L2 distance, for L2 distance, for L2 distance, this galvanometer indicate a zero deflection, null deflection. Then what's happened? Epsilon 2 is equals to, or E2 is equals to V by L into L2. V by L, K. E2 is equals to K2, K by L2. This is the second equation. 1 by 2. Then we'll do 1 by 2. We'll do 1 by 2. 1 by 2. We'll do 1 by 2. Then what's happened? Here, E1 by E1 by E2 is equals to K L1 by K L2. K gets cancelled. E1 by E2 is equals to L1 by L2. Here, if you know one EMF of battery, then you find out the other EMF of battery by using this principle. By using this principle, EMF of first battery, EMF of second battery. If any battery of EMF, if you know the any battery of EMF, then you will find out second EMF of battery. To find out second EMF of battery, this is the comparison of EMF of battery. Next one, next one, next one, to determine internal resistance of cell, internal resistance of cell. Third use, third use of potentiometer, third use of potentiometer, third use of potentiometer to determine, to determine internal resistance, internal resistance of cell, internal resistance of a cell. Okay, how to determine internal resistance of a cell? Okay, right, let us see what is that potentiometer. This is the potentiometer. This potentiometer, this is 0, this is V. Okay, this is V potentiometer wire. This one is the potentiometer wire. This one is the potentiometer wire. This potentiometer wire is connected to one battery, one battery. Okay, internal resistance of that one. Next one, known resistance, resistance box connected to resistance box. This is indicate R. Total, if you your key K key, K, this is the K. This is total circuit connected to galvanometer, galvanometer. Then what's happened? That galvanometer connected to jockey J, galvanometer connected to jockey J. Okay, jockey J. Okay, right, jockey J. Right, this is the A, this is the B. Then what's happened? If K is open, if K is open, this is the primary circuit. Here potential difference 0, here potential difference V is there. Total for here L1, L is there. Okay, L1 and L2, whatever is meant. This one is the L1. Okay, if you take L1, this open, K is open, this total circuit epsilon. Okay, or E. E is equals to, how to write this total resistance? R is there. internal resistance of battery or internal resistance of battery or for this circuit, then what's happened? Epsilon is equals to V by L into L1. V by L, K into L1, K into L1. That is the EMF of battery. That is the EMF of battery. If K is closed, if K is closed, if K is closed, here in this circuit, for this circuit, what is the resistance? Total resistance R plus R, R plus R. What is the total resistance? R plus R. This is the battery. This is the battery. How much of current passing through this circuit, internal circuit? How much current passing through this total internal circuit? For year to year, total zero. But in this circuit, for internal, in this circuit, I is equals to V by R. V means epsilon or E by R. R means total resistance. If connected, total resistance of these resistors are connected in series, R plus R, R plus R. This is most important. Okay, right. What is that here? Potential drop, here 0, here E is there, here R is there, R is there. What is the potential drop for here? Here battery E is there, that internal resistance, another end. For this, what is the potential for this? Here 0, here to here E is there, here R is there, R is there, I1 is there. I total how much? How much potential drop at this point? Minus IR. E minus IR. E minus IR. For this potential drop,
Sir,
E
conclude the session,
minus
sir.
IR. E minus IR. E minus IR. Then what's happened? This total V by L. E total drop, your potential drop, V is equals epsilon E is equals to then what's happened? E minus IR is there. Total potential drop E minus IR. This total, then how to write? L potential drop, total potential drop V by L into L1 is equals to E minus IR, E minus IR, E minus IR. Okay, that is the if closed I2 is there, L2, sorry, potential drop L2 V by L for L2. This one is the L2 when key is closed. Okay, L2. Then what's happened? What is the potential drop at this point? At this point, minus IR. V by L into L2 is equals to E minus IR. E minus IR. E minus IR. Here I is equal to E by this value substitute in this equation. V by L into L2 is equals to E minus I, E by R plus R into R, R plus R into R. Then V by L, L2 is equals to, if you E common, then how
Sir,
to
conclude
write?
the session, sir.
1 minus, సార్ అయిపోతుంది total, right? 1 minus R by R plus R by R plus R, E, if you do the LCM, R plus R minus R by R plus R, then R gets cancelled. V by L into L2 is equals to E R by ER by, this is the R, not smaller, smaller. This one is the smaller, small r. Then which one is cancelled? RR gets cancelled. ER by R plus R. ER by R plus R. This is the second equation. If you do first by second, then what's happened? epsilon by epsilon v, v by L, v by L into L1 by next one, v by L into L2 is equals to, this is the E is there, E by E R by R plus R. E gets cancelled, V by L gets cancelled. Then what's happened? L1 by L2 is equals to, this take over friends, R plus R by R. Or this is the, how to write uh, R plus R by R plus 1 is equal to L1 by L2. R by R is equal to L1 by L2 minus 1. R is equal to R into L1 by L2 minus 1. This is the most important for IPE. This is the most important for IPE. Okay,
Complete answer.
complete.